In this video, we are going to analyze the motion of an object moving at constant velocity. The first thing that I did was I went to my camera roll and I made a video of an object moving at a constant velocity. I have a toy car here that moves at a constant speed. You could also use a rolling ball. You could use a running or walking person. Really anything will work. So after I take that video, I'm going to go to an app called Video Physics, and I'm going to press the plus button, and I'm going to choose that video. And I'll edit it a little bit because I don't need the whole thing. So I'll start right there, and I'll use the video. Oh, it cut my whole thing. Sorry about that. Let me go back. Let's try that one more time. I'm going to choose an existing video. I'm going to start there. There we go. Gotta get the yellow. All right. Okay, I'm going to use that portion. There we go. That looks better. So, perfect. Okay, now I'm going to back up here. Now the first thing in a video like this that we need to do is we need to identify the origin and the scale. So I'm going to call the beginning of my meter stick the origin. Now I put a piece of paper out here because if you don't have a meter stick or a ruler, you really could use anything. You could use anything with marks on it. If you could just use a piece of paper, and I'll show you how to do that in just a minute. Okay, so I'm gonna set I went to origin and scale. I'm gonna set my origin. And then if you have a meter stick, you can set the meter stick to a certain number of pixels. So there, I've got that. Now, again, if you don't have a meter stick and you just have something like a piece of paper, I can use the piece of paper in the same way. The difference is a piece of paper is 28 centimeters, so that would be 0.28 meters. That will achieve the same result. Okay, so I've got an origin and a scale for my setup. Now I'm going to go back over to points, and I'm going to pick a point on the car, and I've chosen the beginning of the car, and I've tapped this circle to make a point. Okay, now I'm going to step the video forward, and I'm going to tap this again. And you'll see every time I make a point by tapping the crosshairs. There we go, now we're cooking. And I keep trying to hit the very front of the car. Okay, let's do, that looks pretty good. You don't have to do a whole bunch. I've got, I don't know, 12, 14 points there. That looks good. Okay, then we're gonna press this graph button in the upper right-hand corner, and we see the X and Y position, And actually what I'm really interested in here is the X, the horizontal position. So that looks pretty good. The top graph looks nice and straight. So what I'm going to do next is export this to graphical analysis. Sometimes graphical analysis won't come up, and if that's the case, then what you need to do is go to graphical analysis and open it. And then go back to video physics, and let's try it again. Oh, let's try open in. How about that? There we go. I had to be kind of persistent. So now I see graphical analysis. And there's my data. Now, this is graphing both horizontal and vertical data, but really all I want is the horizontal data. So I'm going to turn off the Y data. I don't need it. And I'm going to turn off the Y velocity here. Okay, now let's analyze this. This is a position time graph. I'm going to look at just the top graph, and down in the lower left corner, I can apply a curve fit. I can apply a linear curve fit. Now, I might decide that some of this data isn't what I want to use. In that case, I can change my range. Remember, range are the possible X values. And there I've got a really, really nice fit. Okay, I'm going to take a screenshot of this, and I'm going to put it into Notability. So the purpose of this lab was to look at constant velocity, the constant velocity of an object, and there we go. There's my picture. Look at the constant, look at an object moving with a constant velocity, pardon me, and analyze that velocity, or analyze that motion in terms of a position time graph. So here we have a position time graph, and here I've got my equation, y equals mx plus b, and I have an m and I have a b. So now it's my job as a physicist to convert, to actually write out this equation properly. So I know that y equals mx plus b. So it's tempting to write y equals 0.438 x plus negative 0.019. See what I did there? I plugged in m and b into the equation. And that's partway there. But in physics, what we need to do is add units and variables. So the units, on the y-axis, we have position. 0.438 is our slope. And our slope is our y unit over our x unit, and it equals the velocity. The horizontal variable is time. And then our y-intercept is negative 0.019 meters. Okay, so again, I was using the vertical and horizontal variables and plugging those in to write my equation properly. The slope is the velocity of the object, and the y-intercept is the initial position. Ideally, the initial position would be 0, but there's always some error when you're landing those points. If I go back to graphical analysis, and if I look at the x velocity graph, here we can see, I'll take a screenshot of this as well. Here's the velocity time graph, and this is a little messy, but basically if I look at, oops, sorry about that. If I look at this part here, this is the constant velocity portion, and the more perfectly you do this, the closer you'll get to a horizontal line. And that constant velocity is about 0.43 meters per second, and I'm reading that right off of this scale on the vertical axis. If I go back up here, again, remember that velocity indeed is about 0.43 meters per second. So this is what it looks like on a position time graph. Also, remember that graphs are always labeled as y versus x. It's like you're reading from left to right. And this is a velocity time graph. Okay, so those are the skills you need to complete the constant velocity